Okay, so we will be start with the electronic, okay? And that means you can working on the left-volt semiconductor circuit board. First thing, that's just a review. You know, when you see the signal, that's basically just a sideways, okay? And this will be time. What that means? That means the time domain. The signal vary with the time. And that's what they call positive alternation and a negative, okay? And this is a basically definition. Try to read over and over, okay? What is a cycle? One complete occurrence of repeating wave periodic signal, such as one positive and one negative alternation of a sideways. This is a positive and this is a negative. Complete one cycle. And they keep running forever. Okay? And what is the frequency? The number of cycles of a signal occur in 1 second. That means from here to here, that's the 1 cycle. And that will be 1 second. Okay? Period. The time distance between two similar positions on a periodic wave. Wavelength. That means this is a wavelength. Okay? That means the signal transmitted over the air. Okay? And here is not the time, but that will be the distance in meter. When you're learning RF, radio frequency, then you deal with the wavelength. This is how calculate the lambda wavelength, okay? We don't care about that. Now, when you see the signal here, sideways, on the oscilloscope, okay, they only display on the oscilloscope. They say they set a 1 volt per division. That means this is a 1, 2, 3, 4, 5, 6, 7, 8 division. H1 will be 1 volt. So the V peak means from the 0 to the top. 1, 2, 3. So that's why V top equal 3 volt. Okay. V peak. And next one, V peak to peak, that means from the top to the bottom here. 1, 2, 3, 4, 5, 6. They will be 6 volt. If you want VRMS, in here they're not telling you anything about VRMS. The thing is when you measure the sideways with the meter, DMM, then you get the VRMS. However, if you want to get the VRMS, then this is the formula. You take 0.707 times V peak, that given you VRMS, or also given you the average voltage. And it would in the display 1 millisecond per division. If you're going from left to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 division. That's for the time. Okay? Up and down for the amplitude or the voltage. So 1 millisecond for division. So if you're going from here to here, one cycle. 1, 2, 3, 4, 5, 6, half, and the half will be 7. Okay, this is the one complete cycle. Period. So that's why period equals 7 milliseconds. If you want to see what the frequency, oscilloscope here cannot measure frequency. So you have to using the formula F equals 1 over T. So that's why you can get the frequency. Okay, however, you're working on the left in the program. We're using the different oscilloscope, more expensive than the analog scope. That means a long time ago. So for the new oscilloscope in the lab, they can measure the frequency for you. They can measure the VIMS for you. Simple thing is they using the formula to calculate to display for you. However, the cost will be get have to pay more. Okay. Now, first thing we have to deal with that what we call a diode. Okay. They can be built for the diode using the silicon diode or the magnesium. That means a different material. Now we're talking about silicon diode. So one side N-type, they get a negative electron, positive on the P-type. Okay. When you get the power enough, so the electron will be moving from the right side to the left side. That's why you get the current flowing, electron flowing. You understand me? We're working with a conventional current, electron moving from right to left. However, for conventional current, we'll be going from left to the right. That's just the only one current. And then this is the physical. And that will be symbol for the diode. When you're looking on that thing here, you know this is a diode. A means anode, C means cathode. And the voltage from A to C, that means the VD. VD means diode voltage. So you can see diode voltage VD equals VA minus VC. Okay? We don't care about the physical. We really care about this symbol here. Okay? Make sure voltage from A to C. That's what we call a VD. And have to be equal voltage A minus F voltage at C. Okay? Diode normally permit electron current flow only one direction. Okay? Electron current, that means basically that current. only the current flowing from A to C, and they cannot flowing from C to A. That means only one direction. Okay, now look into here. First thing they say, ideal diode. That never happened, okay? But we still bring it up here. This is the ideal, okay? So if they allow the current flow, they just like the wire. Not VD. VD equals 0. Okay? So that never happened. Now we're talking about practical diode. Okay? Reverse bias. Them diode, like the switch, they open. Okay? Only thing is they open, they not allow any current from A to C. That's it. And now, if the diode conducting, okay, then the current, like the switch, they close. Current can be flowing from anode to the cathode. So very simple thing. When you're working with the diode, if you don't know the diode will be on or they will be off, you cannot solve any question, anything. So very simple thing. When you're looking into the circuitry, then you need to recognize it is a diode. And a diode, they can be on. That means they allow the current flowing from anode to the cathode. Or they will be off. That means they open, no current flow. They're telling you they off here. Look like the switch open. And this they on. The switch is closed. Current can be flowing. If you don't know they on or they off, you cannot do anything with the circuitry. Okay? So if you get any question, anything, just let me know. Try to make clear for you basic things you have to know in order to get involved into the electronic.
I have a question.
Yeah.
So we're talking about the resistance is infinity. That's one direction only.
No, what you mean resistance?
So so the diode when it acts as a open switch, it's got infinite resistance.
Yeah, that means open. That means resistance will be infinity.
Okay.
Or they will be closed. Resistance will be 0. So the current can be flowing.
Okay. So it acts like an open and closed switch.
Yeah, just closed switch.
Okay, thank you.
Okay. Now, second approximation. This is a diode. When they open, no current can be flow. Okay. And when they on, that means they close here. That means they allow the current flow. How come you get 0.7 here? 0.7 volt. That means if we're using the silicon diode, then instead you draw the diode, you will be draw the power supply 0.7 volt. Substitute for the diode when you're solving the problem. Okay? Now we'll see what happened here. Okay, now you see the circuitry with a diode. So if you're looking into the circuitry, then you have to know the diode will be on or the diode will be off. And you understand the VD. VD means the voltage across the diode. That's what you call a VD. And basically that will be A. That will be C. And VD, you know that equal VA minus VC. Okay? So in this case, what VD equal?
.7 volts.
VA equal what here? They will be 5 volt, right? You see that? VA at this point here, 5 volt. What VC?
.3.
No, I asking VC only.
5 volts as well.
No. It's 0, right? This to the round, nothing. That will be telling you that will be 5 volt. That means across or only thing I want to telling you, you can say diode on. That means conducting. That means they allow the current flowing here. You see that? I'm not telling you solving the problem. No. I'm just telling you the diode, is it on or off? So you see on the left, at point A, you get 5 volts. At point C, basically, the 0. So that 5 volt higher than 0.7 volt for silicon diode. So the diode will be on. That means the first thing you have to know they on or they off. Now they on. The circuitry have to redraw it this way. The diode now substituted by the battery. Plus minus 5 volt. And the voltage here will be positive. This will be negative 0.7 volt. That means you substitute by the battery. And the value 0.7 volt for the silicon diode. 0.3 for germanium, but we don't care about that now. We deal with a silicon 0.7 volt. So from this circuitry, you go to the next circuit. Just redraw, but it's not no more symbol for the diode. Diode already replaced by 0.7 volt battery.
So was V out 5 volts,
What we are equal?
5 volts?
No,
4.3.
5 minus 0.7.
exactly. Okay, by the way, I showed you a few things. Now you get a battery. In series. Five volt, 0.7 volt. So the voltage will be equal how many volts here?
5.7.
5.7. You add them up. Perfect. Now, if you get connected with negative, positive, positive, negative. 5 volt, 0.7. So the voltage will be
4.3.
perfect. 5 volt minus 0.7 volt, 4.3. They're telling you for the battery, connect in series. Okay, if they connect this way, positive, negative, positive, negative, positive, negative, add them up. However, if they positive and they get positive, you have to get the difference. Okay, they're talking about power supply connect in series. So now V out here they will be equal what? 5 volt minus 4.3. Okay, if you get any question, let me know. Try to make it clear. And if you see the current will be flow this way. If you want to calculate the current, I, okay, equal V out divide R1. That's just the law. You get the V out, you get 100 ohm. That you're able to calculate the current. Okay, any question? Anything?
So the current will be V over R1, which is 4.3 over
100 ohm. Right? 4.3. 100 ohm. When you divide, you get an ampere. That's just the ohm law. I equal V divided to R. V equal I times R. R equal V divided to I. That's the ohm law at the beginning for DC fundamental. Okay, so now, in order to know the diode will be on or off, then you have to know the voltage. Okay? Between anode and the cathode, VD. Now I given you this circuitry. Okay? The diode on or off on that circuit. Let me know.
diodes off.
Diode off. That's the one answer. Who else? Remember, this is a negative voltage, right?
Hey, Mr. Pham,
Yes.
just a statement only. So with diodes, the diode, we want the anode to be more positive than the cathode, correct?
Perfect. Now, first thing you have to know VD. That's a diode voltage. We already know VA minus VC. VA will be 0. Right? Ground. Minus VC. VC will be minus 5. So what you get? 0 minus minus, that means you get 5 volt. VD equal 5 volt greater than 0.7. That means the diode will be on. The thing of what I'm saying, you're working with a diode, you don't know diode on or off, you cannot do anything. Okay, any question? Okay, if it's not, try another one. Tell me on or off.
I would say it's off.
You say off.
Yeah.
Okay, now you can calculate here, you can see 2 volt minus 6 volt minus 4 volt. Right? Less than 0.7 volt. So the diode will be off. And they off, they will be look like A here, C here, open. That means the current cannot flow in from A to C. So now you can recognize the important when you're working with a diode, very simple thing. You have to know the diode on or the diode off before you can do something else. So in order to do, you need to get the VD at the anode different with the VC cathode. If they greater than equal 0.7 volt, they on. If they less than 0.7 volt, they will be off. Okay, any more questions? Look like okay. Let's see. Now, let's see. Number 1. You see that circuitry. 10 volt. 1 kilo ohm you get here. Diode. Calculate diode on or off. That's the first thing. Okay. You tell me on this circuitry diode on or off.
It's on.
On or off.
On.
On. Now, how do we know that on? That means you know that the VD right here. Right? How many, if they on, they how many volt? A here. C here. If they are, what the VA to C?
volts.
Oh, come on. I asking a voltage A to C. That means VAC.
Was it 9.3?
No. I asking about VAC across the diode.
0.7.
Perfect. 0.7 if they on. What I already telling you. If right now I said they on first, okay? However, if they on, I don't have any more diode. You have to substitute the diode by the battery. And this battery will be positive here, negative here. And positive, negative, and the value will be 0.7 volt. Okay? So you can see the diode here. Positive, negative, A here, C here. The value will be 0.7. If you say they on, then you have to substitute the diode by the battery. 0.7 volt.
Hey, Mr. Pham, can you draw like you did on the previous one? How you showed VD is equal to VA minus BC to show what the output would be, V out?
No. Right now I'm talking about if you say the diode on, right? Is it correct?
Yes, the diode is on.
Diode is on. Then now you substitute this diode by this battery here.
But in a circuit like this, that well, I know that it's on, but I mean, that formula, doesn't that help you to see that it's on? Where, okay, you got the battery, you got the resistor, and then you got the diode. And at the top of the anode is V out. So I know if you go like plus, minus, you'll see that there's a plus on the anode, which means it's more than likely on. But I was hoping to see that formula again.
No. Right now I just said, if you said diode on, right?
Right.
Then you not see that one anymore. Right?
Okay.
You see that one. You substitute the diode by the battery.
Well, let me ask you this then. Since the cathode is grounded, we know that the cathode is 0. So then the anode's got to be a higher potential, which would mean that it's on, correct?
No, I'm not talking about how do we know they on, okay?
Oh, okay, okay,
I'm talking about if they on.
okay.
If they on, you have a no more diode here. You have to substitute diode by this battery. So look like I can draw that one, you can recognize. Battery. Plus minus 0.7. That means you don't see that. Is it correct?
Right.
Okay. And now, I will telling you, how do we set the diode on? Okay. So, first thing, if you want to know the diode on or off, okay, first thing, suppose you don't have any diode here. Open. Okay, what we out? If you open right here, no diode. What we out?
10 volt.
Correct. You just don't know why. Let me know. The thing is, when you open here, the current flow here equals 0. The thing is open circuitry, no current flow. Equals 0, the voltage across this resistor will be 0. That means 10 volts, they not drop any voltage, so they get 10 volts. And 10 volts compared to 0.7 volt. That means 10 volt here, down here, they're telling you they will be higher than 0.7. That's why I say the diode is on. Okay, so now, if you want to know the diode on or off, first thing you suppose no diode here. What the voltage here? If they higher than 0.7, they are. If less than 0.7, they will be off. Okay? And after they on, you substitute the diode by the battery, 0.7 volt. You see no more this symbol. So in this question number 1, diode will be on. You get that? Tell me what V out. That means what V out equal. If the diode on.
The 9.3.
You say 9.3?
Yeah.
Who else?
Uh, 9.3.
Okay, another one, 9.3. Who else? Mr. Smith.
The majority, it says 9.3, the whole class.
Gee, man. Now, they want V out. I get a meter. I get a GMM. Positive, negative. When you measure V out, that means positive connect here. Correct?
Right.
How about
Negative go to
negative?
ground. Negative go to ground.
Okay, go to that. Okay, if you did agree with me, let me know. So basically, you measure the voltage from here to here. Correct?
Correct.
Okay, now, very simple thing. You want to measure your car battery. What the voltage you get?
We
You
get
take a meter to measure
12
your car
volts.
battery.
12 volts.
12 volt, right?
Yes.
Okay. That only telling you one thing. Even your car battery connect into your vehicle. Whatever, we don't care. However, when you measure the voltage across the battery, you get that battery voltage. So the answer here will be 0.7. When you measure across the battery, you must get battery voltage, no matter what. You get that? Or who else not agree with me? Okay? You want to calculate the current I. I equal V out divide. No, I equal V divide R. Okay? And what V equal?
10 minus 0.7 divided by 1K.
That means 10, right?
Right.
Minus 0.7
7.
divide 1K. So that I'm not doing calculation. You guys do it. I just given you the formula. And if you get VR, I you get I, you get R. Then you can get VR. That means the voltage drop across the resistor. Okay. Now, quickly go to number 2. Diode on or off.
Diodes off.
Off. Perfect.
Oh,
Off. Telling me number 2. VR equal
5 volts.
5 volt. Correct. The thing is diode off, that means open.
No current flow.
Exactly. And what the current I?
No current flow.
Correct? 0 amp. The thing is open circuit. That one, VR. That means the voltage across resistor.
No current flow. So there's no voltage drop across the resistor.
That is the answer. Okay, any question about this 2 problem? Anything is not clear, let me know. Okay, look like you guys okay. Number 3. Diode on or off.
Diode off.
Off. That's the correct answer. Make sure you know how they be off.
You have 8 volts and 5 volts, and it looks like the 8 volt is higher and going in the opposite direction.
Exactly. That means you can get 5 volt higher than or less than 8 volt. So the diode will be off. Current I.
Zero.
Perfect. The thing is you get a diode off the open. Current I will be 0. Okay. So basically, you know the diode on off, easy for you to solve the problem. Number 4.
Diode on.
Okay, the diode on or off, and the answer will be diode on. That means forward bias. On. The thing is, this is a negative voltage, 100 volts. This is a 0. 0 volt higher than minus 100. So that means they will be higher than 0.7. So the diode will be on. So that we're already talking about normally diode. And now we go to the next one. That's what we're talking about Zener diode. This is the symbol for the Zener. This side anode and this side cathode. A here, C here. So when you're looking into the schematic, you need to recognize this is Zener diode. Okay, let's see what happens. A major application for Zener diode is at the type of voltage regulator for providing stable reference voltage for use in power supply, voltmeter, and other instrument. Okay, so normally you can see in the power supply, if they given you 12 volt and they have to get the connect to Zener, that means the voltage coming in more than 12 volt. Then Zener will be activated, so you get Zener voltage. So when you go into the electronic store, you want to buy Zener diode. First thing they will be asking you, what voltage you want? That means when you buy the Zener, you have to tell, okay, I want the Zener diode for 10 volt. Then they given you 10 volt. Okay, that's what they call a breakdown. Without the voltage to let them know they cannot sell you the Zener. Now you go to the next one here, breakdown voltage. That means when the Zener reset breakdown, you substitute the Zener by the battery with breakdown voltage. Like last, I just talked to you about 10 volt. Then that means this will be 10. If you buy Zener breakdown 5 volt, then that will be 5 volt. Okay? So you're looking into the symbol to recognize it as Zener. And now the next thing you have to know, Zener, is it a breakdown or not? And if they break down, then Zener substitute by the battery with the breakdown voltage. Okay? And now, normal diode, if they not break down, they can be working like normal. And you can see this is a normal. Okay? And this side positive, the other side negative, and the voltage silicon 0.7 volt. Okay? When you see the schematic, you recognize this is Zener. Then you can see, is it a Zener breakdown or not? Are they working normal? Okay? Or they can be open, no matter what. Now, see that one here. You get 20 volts. And that's a Zener. Okay? And the Zener voltage will be 10 volt. That means VG Okay, that means when they break down, they will be 10. That's what they given to you here. Okay, now, first thing you have to do, you want to know what the voltage at this point without zero. That means we don't have a zero here. What voltage up there at V out? Without the zero, what the V out?
20 volts.
Perfect. 20 volts. So without, okay, zero, what is V out if V in equal 20? But what I'm saying is 14 without okay? And now, is it a 20 compared to the zero 10 volt? That will be telling you what happened to the zero. They working normal, or they break down, or they open.
Breakdown.
Okay.
Mr. Pham, the input voltage is 20 and the Zener is manufactured such that it's supposed to stop at 10. So it's in breakdown.
Okay. So that's why you can say zero breakdown. And V out. If they break down, that means they cut the output to V zero 10 volt. Any voltage higher than 10, they cut it out. That is the purpose of the zero.
Mr. Pham, quick question.
Yeah.
With regard to the input voltage, which is 20 volts. So when you look at a circuit like this, can you just look at it and say, okay, the input voltage is a positive 20 volts. I got a Zener that's manufactured for 10 volts, And since 20 volts is a lot higher than 10, automatically I know it's in breakdown.
Exactly.
It's okay to say that?
Right.
Okay, thank you.
Okay, that is why you can understand in the digital system, when you go to touch you learn, they're using the power supply only 5 volts. Okay, only 5. So that's why they have to connect that Zener diode with the voltage equal 5. That means any applied voltage higher than 5 volts, they break down. That means you only get 5. The thing is, for the digital circuitry, if you apply the power higher than 5 volts, you cook the IC. So basically, that will be telling you the Zener try to protect the voltage. Like in the computer, they're using 5 volts. They must get the Zener for 5 volts. For some reason, the voltage apply higher than 5. They cut it down. Otherwise, the motherboard of the computer will be cooked. Okay. Now you understand why they need the Zener. Okay, so what V out if V in equal 20? The answer will be A. And vote. Zener breakdown. Okay. What is the current through to 0 ohm? That means they want to get the current flow here. Tell me how to calculate the current.
10 volts divided by
equal
220 ohms.
I equal what? Just tell me formula to calculate it. I equal
V over R.
V over R. However, what V?
V is 20 minus 10 divided by 220.
Perfect. V equal okay. Okay. If V in equal minus 5, what is V out?
If Vn is minus 5, then more than likely the diode will not be in breakdown. It'll be operating like a regular diode.
Okay. So basically, if you get in here minus 5, right? Okay. And this will be the ground. Okay. -5, that means you get -5 without the diode. Without the diode, you get -5. Now you get a diode. That means you get a 0 here. And this side is -5. What we out?
-5.7.
Diode will be on, right?
Yes.
Okay, now you see right here. If diode on, this negative, this positive. So this will be negative. That will be positive. Okay, and 0.7, correct?
Yes.
Okay. That we are talking about C. Okay. So V out. That will be 0.7. Then V out will be equal. That's the answer. And the last one, D. They want to get the current to 220. So now you can say you can get negative, positive 0.7. So on this side, you get negative. So the current will be flowing this way. So I will be minus 0.7 minus 5 divide 220. So that will be 4.3, right?
Yep.
Okay. Hopefully can helping you to understand a little, not much, okay, about the genome. Now, try to get through that one. For this problem here, genome wanted 12 volt. Okay, first thing they say, no load. You don't have any load here. Okay. And they want to know IL. IL, that means the current flow here. That means they remove that. What IL equal?
You said you removed the resistor?
Yeah, that's what they said here.
Zero.
Shown for no load IL. That means you don't have a that one.
Then you got 0.
Perfect. That's very simple. Okay. Now, you get 24 volt input and you get inner 12 volt. So the first thing we want to know, is it a inner breakdown or inner open or inner working normal? First step you have to do, remove inner. Look like no inner. Without inner. What we are?
24 volt.
20,
24.
24. Right?
Right.
24 compared to breakdown voltage 12 volt. So the inner will be breakdown or not?
Breakdown.
Breakdown.
Yep.
If inner breakdown, then VL equal
12 volts.
correct?
Correct.
Yeah, if your guy confusing, let me know. I hope try to training for you like myself. When you're looking at it, you know what to do. Okay? So now you get substitute by the battery, right?
Right.
And the battery will be 12 volt. And that will be calculated IG.
24 minus 12 divided by 470.
IG means the current flow here. Okay, so you take 24 minus 12. Divide 470. Okay.
Twenty-six milliamps.
Yeah, you can do calculation. Okay. But I'm not. And IG. And then they say what we out.
We says in breakdowns was 12 volts, right?
Yeah. Okay. And now they connect the load into the circuitry. That means they connect that one. And they want to know V out. So what V out equal?
Twelve volts.
12 volt, yeah.
Okay, they will be equal. Let's see, V out equal how many volt? 12 volt, right?
12, yeah.
Linear breakdown. IL with the load. How do we calculate the IL with the load? Very simple. You take V out 12 divide 490.
24 milliamps.
Yeah. Okay. And the last one, they want that current. Okay. With the load in the circuitry. Okay, with the load in the circuitry. And you know the voltage. Okay, the voltage at this point will be 12 volt. Okay, so you can calculate the IR. Equal 24 minus 12 divide 470. And IR, that means when they go up here, one will be go here, one will be go down here. So you can calculate the IG. Equal IR minus IL. Okay, that means IR here. Go to this point, one go to G, one go to IL. IL you already know. That means you find the difference. You can get IG. Okay, so up to this point, I will be stopping. Okay, we'll be doing more next meeting. However, that also too much for you guys to do it. Make sure you go through the handout, try to understand. If it's not, this meeting will be put on the web. You can see it over. Okay? Any more questions to me?
Hey, Mr. Pham, so with Mr. Ty tomorrow
Yeah,
on Zoom?
on Zoom.
Okay, thank you.
Mr. Tai, we're talking about the left volt. The important is understanding. Then you don't have to memorize, okay?
I do.
Understanding. Yeah,
Do have a question. So the IL and the IZ would be with the load. So with the 490 resistor.
right, with the load.
Okay.
That's why you can see number E with load, F with the load. Okay,
So it would be the 12 volts over 470 minus the 12 volts over 490.
okay.
Okay, got it. Thank you.
Mhm. Yeah, try to understand every time we get through the lecture, okay? If you get any confusing, not quite understand, just bring it up. Sometimes I can miss something, but okay. I try to explain to you anything I can do. Okay. So, any more questions? Anything else?
Well, I actually do have another question. So in the diodes, the symbol is the triangle. So the top of the triangle will always be positive and the bottom negative
What do you mean a triangle?
of the diode symbol.
Okay, diode simple. Not Zener, right?
Yeah, not the Zener, the diode.
Yeah, that's diode here, right?
Mm-hmm.
Okay, then what? This side positive. This side negative.
Okay.
Yeah, that's at the beginning. You see that? Anode positive, cathode negative.
Okay.
Okay?
Yeah. Does it also apply for the Zener?
Same thing. Positive, negative.
Okay.
That's what you can see right here.
Mm-hmm.
Positive.
Mm.
Okay.
Đó gì nữa?
Okay, I get it now.
So basically, they can be breakdown. They can be on normal like the other diode. Or they can be open. Yep. And only thing what we have to do is know is if they break down or no. Are they on normal? Are they open? That's it. Okay? If you don't have any question, I will be stopped here.
I'm good. Thank you so much.
Oh, you're welcome. Okay, so good night, good weekend for everyone.
Good night.
Good night, Mr. Pham. Good night. Good night.
Thank you.
Thank you.
Good night.
Hello, Mr. Smith.
Yes.
You see this time the lecture is better?
I give you an A, Mr. Pham.
Compared to the past, you know.
Are you?
Yeah.
This no COVID-19. No COVID-19.
No more.
No more.
Okay, good night. Have a
Good night.
everyone. Bye-bye.
Bye.